How's it going? Okay. Hey, Morgan. So you sent me a question. Find the derivative of this guy. So let's see if I can just copy and paste him over here. I guess I can't. All right, I'll just put him in. Y equals x to the x-fifth plus e to the negative 2x. Okay, and I have to find y prime, dy dx. Dy dx. Cool. So when you take the derivative, you have two things here, right? Because we can go through the sums without the problem. So I guess your two rules you have going on here are this one, right? I guess I know d dx of x to the n is nx to the n minus 1, right? And that's what we have right here, right? 6/5 is just a number, right? So this is the power rule, right? And that's going to be something that's different than a to the x, which has the whole natural log and everything involved. But no, it's a constant n, so we're good to go. So we need to know that, all right? And I guess I have to know d dx of e to the x just is e to the x, and I guess we have a chain rule thing going on here, right? All right, so when I take dy dx, right, the thing that I have sitting up here, right, so my n is my 6/5, right? So I'm just going to follow this rule right here. I'm going to say I've got 6/5 times x to the, well, 6/5 minus 1, right? Which I guess is 1/5. And then I'm going to have plus. So e to the x, the derivative of e to the x is just e to the x. But what I have here is a u, e to the 2x. So I've composed these two functions together. So when I do this, I just take e to the negative 2x times the chain rule, the derivative of the negative 2 is just negative 2, right? And then I guess if I just clean this whole thing up a little bit, now I have my answer, right? So 6/5 x to the 1/5 minus 2 e to the negative 2x. And that's it. That's it. I'm done. I suppose that I think maybe if I go into the help me, I can't because that's the publisher. I think they did something weird where they wrote this as 1 over e to the 2x and then did it as a quotient rule. Because I think in 3.3 here, you didn't actually have the chain rule yet. But, obviously, just use the chain rule. And so I would say that's how you do that. I guess the only thing I do want to note that this is 6x to the 6/5. That is actually different from y equals, for example, 6/5 to the x. Right, that's actually not this same situation, so I wouldn't use this rule. The x is up here in the exponent. Well, that's the thing we actually have just been doing. Right, so for what it's worth, now that we're here, right, I take the natural log of both sides. Which then gives me ln y equals x ln 6/5. Then I can just take the derivative of both sides, and I get 1. Oops, go equation editor. 1 over y times dy dx equals, now this x ln 605 ln 6/5 right here, that guy's just a constant. Right? So if it was 3x, the derivative is 3. So if it's ln 6/5x, the derivative is just ln 6/5. Now I just got to bring my, I'm pointing at it like a map. I just got to bring my y over here. Right. And I get dy dx equals y ln 6/5. And y is that guy right there. And I'll just put the ln 6/5 right here. No, that isn't what they asked, but I guess I do just want to point that out because it is coming here. So the thing we had been doing was 6/5 to the x. That's the most recent thing we did. But now x to the 6/5, that's just some constant. So I don't know, you wouldn't treat it any differently. I don't know if it was either negative 2x that was the issue there either. But all right, other than that, if you have any, let me know as soon as I can. Bye. Oh, stop. Never mind.